All right, how many of you attempted it by factoring? By turning it into a complex fraction? Okay. Let's do that. We'll do that method first, and then I'll show you the factoring part as well. All right, when you look at this, you have a negative power, so right away you know it's a complex fraction. It forms, the negative just moves that into the denominator of a single fraction. So if we rewrite this, the x squared will be in the numerator of this fraction. The x squared plus 9 to the 1/2 will be in the denominator. Minus, and just to make everything consistent, I'm going to put this in the form of a rational power. The square root is a power of 1/2 as well, all over x squared. So what I'm going to do is think of every single thing as a fraction, just again to be consistent and organized. And now I'm going to use method 1. I'm going to turn this entire numerator into one single fraction. That single fraction is going to have a LCD of x squared plus 9 to the 1/2 and a 1. So there's our LCD. So we take the numerator of our first fraction, x squared, and multiply it by the LCD factor missing from its denominator. Is it missing anything? No, so just leave it. And then minus the next fraction's numerator, x squared plus 9 to the 1/2, multiplied by any LCD factor missing from its denominator. It's missing the whole thing, x squared plus 9 to the 1/2. So when we multiply same base, what do we do with the powers? And it should almost always kind of work out to be this. 1/2 plus 1/2 is 1. So we're just using this actual expression. If we continue to simplify, we'll distribute our negative through. We get x squared minus 9 all over this common denominator. And so here the x squareds cancel, and I'm left with negative 9 over x squared plus 9 to the 1/2. But instead of dividing by x squared, I'm going to multiply by the reciprocal. So I'll move the 1 to the numerator, the x squared to the denominator. And that gives me my overall solution, negative 9 over x squared. I'll write my monomial factor first, and then the binomial factor next. And so this would be your simplified form for that. Okay. It was the original 1/2, and then we multiplied by the missing LCD factor, which was also 1/2. So 1/2 plus 1/2 was equal to the value 1. All right. If you feel more comfortable thinking of this as a factoring problem, what you would first do is, again, put these in the same form. So instead of a square root, think of this as a power of 1/2. And then what you would do is look to factor. In these two groups of factors separated by a minus, your common base is x squared plus 9. So if you remove the lowest power, the number furthest to the left on a number line, it's going to be a negative 1/2. What remains has to have the same form as the original, so we'll write that in. And now let's go back in and see what's going to be remaining. We're going to subtract a power of minus 1/2 from each of these. Subtracting a negative is like adding the opposite. And so here this entire factor gets canceled out, leaving an x squared. Here 1/2 plus 1/2 is 1, so that you get the whole quantity x squared plus 9. That's all over x squared. Okay. What we can do here is, because we have a negative power, we can move this base into the denominator. So I'm just going to rewrite it here. X squared plus 9 to the positive 1/2. Again, when we move it, it becomes a positive power. I'm going to distribute my negative. So here in the numerator, I get x squared minus 9 all over x squared times x squared plus 9. X squared minus x squared equals 0. They cancel out, leaving your solution the same thing that we got using the complex fraction form.